Hey everyone, Teacher Chang here, and today we're going to go ahead and graph some square root functions. So let's go ahead and get started, and let's take a look at the format. All right, the standard form is in this format: y is equal to a times the square root of x minus h plus k. So a, h, and k are going to be some values, and they're going to tell us different characteristics about this function. So the a value is going to tell us if we have a vertical stretch. Now, if we do have that a value, it's going to stretch out that graph. So for example, if I were to draw this graph, a square root will typically look like this. It's kind of like a half of a sideways parabola. And it's this upper portion right over here where we have the starting point at the bottom left. Now, if we have an a value that is greater than 1, it's going to be stretched out. It's going to be pulled upwards. So it's kind of like taking a rubber band and we're pulling it in an upward direction. We're stretching it out. Now, if we have an a value that's between 0 and 1, well, that means it's getting squashed. It's a compression. So we're kind of flattening it downwards. Now, that's pretty much what our a value does in terms of the vertical stretch. But the a value could also tell us if we have a reflection. And we have a reflection over the x-axis when a is negative. So if a is negative, well, that means our graph is going to be flipped upside down. It's going to go in a downward direction. So it's going to open in that downward direction instead of an upward direction. Let's take a look at our h value. Our h value is going to be our horizontal shift, and that's shifting our graph either to the left or to the right. So we're going to take that starting point, and we're either going to move it to the right or to the left, but it's going to feel like we're going in the opposite direction. And the reason why is because we have a minus sign in front of that h. So if it says x minus 2, well, that means we're going to go to the right 2. And if it says x plus 2, we're actually going to the left 2, because the h value is going to be the opposite of what it says in that equation. The k value is going to be our vertical stretch, which means that we're going to shift our graph up and down from that parent function, and we're going to see that parent function later on. Now, the starting point when we graph our square root functions is going to be using our h and our k values. Now, to find our additional points, we could go ahead and create a table of values, an x and a y chart, and that's what a lot of teachers do. But there's a little trick that we can use, and I'm going to be using something that I call the 1-3-5 trick. The a value will help us locate these additional points by using this trick, and we can also use what we know about our rise and our run. So to find additional points, we're going to rise whatever that numerator is in terms of our a value, and then we're going to take the denominator and we're going to use that to help us figure out, well, how far over do we have to move to the right from each point. So it's going to be the denominator squared times our 1-3-5 trick. Now, that might not make sense to you right now, but I'm going to show you how it works as we go through some of these examples. So let's go ahead and start off with our first example, which is just the parent function. And this is just the square root of x, which is our parent function, because our a value is 1. It looks like it's missing, and our a value can never be 0, because 0 times anything is 0, and well, we want it to be the square root of x. So our a value is 1 in this particular case. The h value is going to be 0. We don't have an h value, and the k value is also 0 because we don't have a k. Now, the h and the k will give us our starting point. So our starting point is going to be located at 0, 0. So we're going to start right here at the origin. Now, we can go ahead and use our 1-3-5 trick and look for our rise and our run. Now, I told you earlier that the rise is going to be the numerator of our a value. So if I take a look at my a value and I write it as a fraction, that's 1 over 1. The numerator is 1. So I'm going to rise 1 every single time. Now, our run, the portion where we move over to the right, that's going to be our denominator squared. So our denominator in this case is also 1, and we're going to square that, and we're going to multiply it with our 1-3-5 trick. Now, if you've never heard of this 1-3-5 135 trick, I'm going to explain what that means. So in this particular case, 1 squared is just 1. And when I distribute it to the 1, 3, and the 5, well, that's still going to be 1, 3, and 5. So this is how I'm going to find my additional points. I'm going to rise 1 from my previous point. So from my starting point, I'm going to rise 1, and then I'm going to run over 1. And that's going to give me a new point. And then to find my next point, I'm going to, again, rise 1. So I'm going to rise 1, but this time I'm going to run over 3 times. So 1, 2, 3. So here's my next point. And then again, I'm going to rise 1 more. And this time I'm going to go over 5. So I'm going to move over 5. 1, 2, 3, 4, 5. And we could do this with the next step. The next step would be our 7. And the next one would be 9. It's all of your odd numbers in case you haven't noticed. So now when I connect these, this is what our parent function is going to look like in terms of a square root. So this is what a square root function looks like. All right, let's go ahead and try one where we do have some values for a, h, and k. So in this particular case, looks very, very similar with that square root of x, but now we have an a, h, and k. So our a value is going to be this 2 here. So that's our a value. What does that 2 tell us? Well, that tells us that we have a vertical stretch with a scale factor of 2. So it has a scale factor of 2, meaning that it's going to be stretched out vertically, and it's going to raise that height of our graph twice its height. Then we have our h value. Our h value is this 3 here, but it's going to be a -3. Remember, it's going to be the opposite of what it says in the equation. Well, that -3 or that -3 in words tells us that our graph is being shifted over to the left 3 units. And then we have our k value. Our k value is -4, which means our graph is going to be shifted down 4 units. Now again, the starting point is going to be from our h and our k. So our starting point is going to be at -3, -4. So I'm going to graph that starting point at -3, -4. This is where we're starting. And then to go ahead and use our 135 trick, I'm going to look at my a value as 2 over 1, as a fraction. So again, the rise is our numerator, which in this case is 2. Our run is our denominator squared. Our denominator is 1. We're going to square it, and we're going to multiply it with our 135 trick. Now, just like before, earlier on, well, 1 squared is 1. And well, if I distribute it with our 135, that's still 135. So let's go ahead and graph our additional points. We're going to rise 2 this time. So I'm going to go up 2, and then I'm going to run over 1. So 1 to the right. So here's our second point. Then I'm going to rise 2 again. And this time I'm going to run over to the right 3 units. 1, 2, 3. Here's our second point, or third point. And then we're going to go up 2 more. And then we're going to run over 5 units to the right. 1, 2, 3, 4, 5. And here's our next point. And again, we would have went up 2 more and then over 7 if we had that space in our coordinate plane, but we don't. So we're just going to graph these, connect these, and this is what our graph looks like. And again, remember, it's bigger because it's being stretched out vertically. All right, let's go ahead and take a look at this next one. Each of these items that I'm giving you will be slightly different. Okay, so in this particular case, this time our a value is going to be -1. We don't see the 1. There is a 1, but it's also negative. So our a value is -1, which means it's not being stretched out vertically. But because of that negative sign, we do have a reflection. So there's a reflection over the x-axis. That means our graph is going to be flipped upside down. It's going to look something like this, okay? We don't have an h value, so there's no horizontal shift, so h is 0. And we do have a k value of 2, so k is equal to 2, which means there is a shift word upwards, so there's a shift upwards by 2, so it's going up 2 units. So now we're going to go ahead and write out our starting point. So the start point is going to be located with our h and our k, which is at 0, 2. And 0, 2 is located right over here. And now we're going to go ahead and look for our rise and our run. So our a is -1, which is the same thing as -1 over 1, which means the rise is our numerator at -1, and the run is our denominator, which again is 1. We're going to square it and multiply it with our 1, 3, 5 trick. So once again, just like before, well, 1 squared, let me bring that back. 1 squared is just 1, and we're just going to multiply that 1 with our 1, 3, 5. So that's bringing us right back to 1, 3, 5. So now we're going to go -1. -1 means to go down 1. So I'm going to go down 1 and then over 1. That's our first one over here. So there's our second point. Then we're going to go down 1 again, and this time we're going to go over 3. So 1, 2, 3. Here's our third point. Then we're going to go down 1 and over 5. So down 1 over 5. 1, 2, 3, 4, 5. Here's our next point. And then we take our pencil and we'll just go ahead and connect these points. And again, it's flipped upside down because our a value is negative. It's not being stretched vertically, so it's the same size, just negative. So it's being flipped upside down. All right, let's try another one. This next one, slightly different. This time our a value is a fraction. So our a value here is going to be 1/2, which means it's going to be squished because it's between 0 and 1. So it's going to be a vertical compression, but a lot of teachers will still say it's a vertical stretch, which is perfectly fine. So I'll write it out as a vertical stretch, but it has a scale factor of 1/2. So it has a scale factor of 1/2 here. Now, we also have an h value. The h value, again, is going to be the opposite. So it's going to be -6. In words, that means it's going left 6 units. And then we have a k value at -2, which means we're going to go down 2 units. And again, the h and the k gives us our start point. So our starting point is going to be located at -6, -2. So -6, -2 is going to be located right over here. Okay, now we're going to go ahead and look for our additional points by looking for our rise and our run. So the rise, once again, is going to be the numerator. Well, the numerator is 1. And then the run is going to be our denominator squared. So that means 2 squared. And we're going to multiply it by 1, 3, 5. So this is a little bit different now because our denominator is different. Well, 2 squared is 4. And, well, we're going to take that 4 and distribute it with our 1, 3, 5. Well, 4 times 1 is 4. 4 times 3 is 12. And 4 times 5 is 20. Now, chances are I'm probably not going to fit that 20 in there. And I might not even be able to fit that 12, but we'll take a look when we go ahead and look at our graph. So we're going to start off with our rise. Our rise is 1. So I'm going to go up 1, and then I'm going to go over 4 this time. So I'm going to go over 4 units to the right. So here's our first point after our starting point. Then I'm going to rise 1 and over 12. So I'm going to go up 1 and over 12. Well, that looks like it just fits all the way to the end of our coordinate plane. So I'm obviously not going to fit in that 20. So now I have this. Now I can draw my square root function, and we can see that it is going to be very flat. So it's kind of like taking our original square root function and flattening it down half its size. All right, so let's go ahead and take a look at one more. And if we take a look at this one right over here, same thing. We do have an a value, and it happens to be a fraction. But this particular a value is actually going to enlarge in our original parent function. And the reason why is because the 3 over 2 is 1.5, and that's greater than 1. So our a value is 3 over 2, and it is a vertical stretch, not a compression, because it is greater than 1. So it has a scale factor of 3 over 2. So it is going to get a little bit larger. Now we do have an h value. The h value in this case is -8. Remember, it's the opposite, which means in words left 8. And since we don't have a k value, our k value is 0, so we're not shifting it up or down any. Again, we're going to have our starting point, and our start point is going to be at -8 0. So it's our h and our k value. So negative 8, 0 is located right over here. All right, so now we're going to go ahead and use our rise over run, or our rise and our run, and we're going to use that 1, 3, 5 trick. So the rise is the numerator, which is the 3, and the run, again, we're going to take the denominator, which is the 2, and we're going to square it. So it's going to be 2 squared, and we're going to multiply it with our 1, 3, 5 trick. So if we go ahead and do that, well, 2 squared is 4, and then we distribute it to our 1, 3, and our 5. Well, 4 times 1 is 4, 4 times 3 is 12, and 4 times 5 is 20, and once again, we may not fit in that 20. So let's go ahead and see what this graph looks like. We're going to start off by rising 3 from our starting point. So rise 3, and then it says to run 4. So we're going to go over 4 to the right. 1, 2, 3, 4. All right, now we're going to go ahead and rise 3 more and then go 12 to the right. So we're going to rise 3 more and go 12 to the right. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so there's our next point. And obviously, we're not going to fit in that 20. And, well, we go ahead and we just connect them. And this is what our radical, our square root function is going to look like when we have an a value that is 3 over 2. All right, that's how you graph it. That's how you go ahead and use your A, H, and your K to help you find your vertical stretch, your horizontal shift, and your vertical shift. And we can use our A value to help us find our additional points by using that 1, 3, 5 trick. All right, I hope this helped out. If you have any questions, go ahead and leave a comment. And don't forget to like the video and subscribe. All right, good luck, enjoy, and have fun.